Okay, so today we are going to talk about something called arithmetic sequences. The objectives for today are to, 1, be able to describe and extend relationships between terms in an arithmetic sequence. And I want you to be able to write an algebraic expression to represent an arithmetic sequence. So 3 important vocabulary terms today. A sequence. So a sequence is an ordered list of numbers. So it's a list of numbers that has some order to it, some pattern. Each number in a sequence is called a term. Okay, so each unique number that forms this pattern of numbers is called a term. In an arithmetic sequence, each term is found by adding the same number to the previous term. So that's what we're going to be talking about today, arithmetic sequences. So let's look at these 2 examples. In the first example here, this is a sequence because it's a patterned list of numbers. Each number is called a term. So I'm just going to label it term 1, term 2, term 3, term 4. So there are 4 terms in this sequence. The pattern in this particular sequence is +2. So let me erase what I just wrote for you. +2, +2, +2. That's what makes this particular sequence an arithmetic sequence, because in between each of the numbers, you're adding the same amount each time. Same thing with this sequence. So this sequence, we start with 0.7, and then we go to 0.6, 0.5, 0.4. So it appears that this sequence is actually decreasing, but that's okay, because we're adding -0.1 every time. Okay, you can see that we're adding -0.1. So that's still an arithmetic sequence. Okay, so those are 2 examples of arithmetic sequences. In an arithmetic sequence, each term is found by adding the same number to the previous term. Okay, so we're going to look at an example. The number of students who went on each horseback riding trip is shown. Do the numbers represent the terms of an arithmetic sequence? Explain. Okay, so I'm going to pause here. I want you guys to answer this question, and then we'll go over it. Okay, so let's look at the pattern that we see. So trip 1, there were 15 students. Trip 2, there were 16. 3, 18, 4, 21, 5, 25. Let's see, from trip 1 to trip 2, we have +1. From trip 2 to trip 3, we have +2. Then we have +3. Then we have +4. So what we're going to say here is this is not an arithmetic sequence. It is a sequence because it is a pattern, but it's not an arithmetic sequence. So we're going to write this is not an arithmetic sequence because you are not adding the same number between each of the terms. Okay, you're not adding the same number between each of the terms. While this does form a pattern, it does not form an arithmetic sequence because we're adding 1, then we're adding 2, then we're adding 3. The numbers change, so that's not an arithmetic sequence. Okay, in this next section, we're going to practice describing and extending a sequence. Okay, so the first one is done for us. It says, describe the relationship between the terms in the arithmetic sequence 8, 13, 18, 23 then write the next 3 terms in the sequence. So here we describe the sequence by saying each term is found by adding 5 to the previous term. So this is describe. And then we continue the pattern to find the next 3 terms. We get 28, 33, and 38 because we keep adding 5. So this part is called extend. So we are able to describe and extend a sequence. Okay. Same thing here, another example. Describe the relationship between the terms in the arithmetic sequence 0.4, 0.6, 0.8, 1.0. Then write the next 3 terms in the sequence. So here we describe the sequence. We say each term is found by adding 0.2 to the previous term. Now we want to continue the pattern, so we want to extend the sequence. So we're going to take where we left off, which was 1.0, and we're going to add 0.2. That gives us 1.2. Then we're going to take 1.2 and add 0.2. That gives us 1.4. Let me shrink this a little. And we're going to do it one more time because we want to find the next 3 terms. So 1.4 plus 0.2 equals 1.6. These are the next 3 terms in the sequence. Okay? So now you're going to do these 2 got it problems. Okay, let's move on to the last section, which we're going to write an algebraic expression for an arithmetic sequence. So it says, in a sequence, each term has a specific position within the sequence. So we're going to look at the sequence 2, 4, 6, 8. Okay, each term, meaning each number in the sequence, has a specific position. So the number 2 is in the first position, the number 4 is in the second position, the number 6 is in the third position, and the number 8 is in the fourth position. We notice that as the position number increases by 1, the value of the term increases by 2. So as the position goes up by 1, so as the location of each term increases by 1, the value of that term is increasing by 2. So you can write an algebraic expression to represent the relationship between any term in a sequence and its position in the sequence. In this case, if n represents the position in the sequence, the value of the term is 2n. That means if you take the number 2 and you multiply by the position number, you will get the value of that term. That should be in that particular spot in the sequence. Okay, so we're going to try this one. An algebraic expression for a sequence relates the position of each term to a certain factor used to determine the value of that term. So in this sequence, we have the 4 is in the first position, the 8 is in the second position, 12 is in the third position, 16 is in the fourth position, and so on. So in order to get the value of each number in each particular position, you are multiplying by 4. For example, 1 times 4 is 4. 2 times 4 is 8. 3 times 4 is 12. 4 times 4 is 16. Okay, so we can actually take 4 and multiply by the position number, and that will give us the value of the term in that spot. So the expression here would be 4 times n. And also we get the number 4 by looking here, plus 4, plus 4, plus 4. All right? Okay, let's try this one. If the pattern continues, what algebraic expression can be used to find the number of circles used in any figure? How many circles will be in the 50th figure? Okay, so figure number 1, which would be in the first position, has 3 circles. Figure 2 has 6 circles. Figure 3 has 9 circles. So this is an arithmetic sequence because we're adding 3 each time. We can also figure out the number of circles in any figure number by multiplying the figure number by 3. So that expression is going to look like this: 3 times n, okay? So if I wanted to know how many circles would be in the 50th figure, I would multiply 50 by 3. So I'm plugging in 50 for n to get 150, okay? So not only can I describe a sequence by saying what I'm adding in between each term, I can extend a sequence by continuing to add on to the last term. I can also write an algebraic expression using the position number to figure out the value of a term in any spot in a sequence, okay? So I want you to try this last one for the example classwork, and then you're going to complete the worksheet that is posted, okay?